6.2.4. First one, they give you three shapes. You have to find the area and the perimeter of them. I'll do areas first because those ones are usually a little bit easier because you just have to look at the shape. First one, we have an x squared plus an x tile plus, remember the little ones are 1. That's the area for the first one. Second one, x plus 1. Third one, we have an x squared plus x plus another 1 tile. We can simplify that or combine the things that are the same. So we have an x squared plus 2x's plus 1. Either of those answers are technically correct. Now we gotta go back and do the perimeter. And again, if you're having trouble with the perimeter, it always helps to draw it out. So I'm gonna just label the sides for the first two, x, 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 1, 1, 1, x, 1. And actually, this side here is x minus 1. Because remember, this little side here is 1, so we have to take that off. So we're left with 1, 2, 3 x's plus an x minus 1 plus we have 1, 2, 3, 4 ones. So I'll just put that as plus 4, right? Now we really should be able to combine things that are the same. Combined, we call them like terms, right? So we have a minus 1 and a plus 4 that gets us plus 3. And then if we combine the x's together, we get 4x. Okay, that's the first one. Next one. Again, I'll label the sides. Let me erase this one here. We have an x. We have a 1. And again, here we have another one. So it's x minus 1 again. 1, 1, 1, 1. So we're left with x plus 1 plus x minus 1 plus 1, 2, 3, 4. All right, so I can combine the things that are the same again. 2 x's plus, and if I look at this, I have a plus 1 and a minus 1. Those would make 0, so I'm just left with plus 4. All right. Next one, last one, I'm not going to label all the sides on it, but you can totally do that if you would like. This one, we're left with, I'll label the sides, why not? x1, x1, x minus 1, 1, 1, 1, 1, x 1. So I'm left with x plus 1 plus x plus 1 plus x minus 1 plus 3 plus 1 plus x plus 1. Now, that's really long and confusing, but I'm going to combine all the things that are to get the same. X, 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 x. 4 x's plus 1 plus 1 is 2. Minus 1. 2 minus 1 is 1. Plus 3 is 4. 5, 6. Plus 6. That's the answer to the first or the last one in the first question. Question 107. Okay, here we go. First things first, I'm going to combine the things that are the same first. So you'll notice here, I have a couple x squared. So I have 2 plus 3. That's 5x squared plus, if I look now, I have x's. 7, and remember there could be a 1 there. 7 plus 1 is 8x plus 3. There's no other numbers there. Once you do that, you can open this link up, and it'll take you to the algebra tiles. Then all you have to do is make it. So again, there was 5 x squareds. Okay. There were 8 x's. 3, 4, 5, 6, 7, 8. And then your 3 ones. 1, 2, 3. Okay. So that's what your picture should have looked like. They could have been in any order, but it should have looked something like that, right? Next problem. All you have to do here is make a number line and like an area model, a drawing to show what these fractions will look like. First one. Here's my 1 hole. Here's my 2 holes. Notice it's 1 2/3, so I need 2 holes. I got 1 whole one. Then I have to split the other one in thirds, and I have 2/3 of that. All right. Number 2, still over 100%, so you need one whole one. And then I should know 25% is the same as 1/4. If I divide this into fourths, I will have one of it. All right? And then if I did them on a number line, 0, 1, 2, okay, 1 2/3. Split that into thirds. Here's my 1 2/3. And then fourths. I'm going to split the same thing here into fourths. Okay, here's my 125%, which is the same as 1 1/4. Question 109. This should be a real quick one. First one says, how many 8s are in 5 5/8? Well, remember, this is just making a mixed number into an improper fraction. So I'm going to take the 5 5/8, okay, and I'm going to do, remember, the whole number, which in this case is the 5, times the denominator, which is 8, because that's going to tell me how many 8s are in 5 wholes, and then I'm going to add the top 5. So obviously when I do this, I get 8 times 5 is 40, plus the other 5, so it's 45/8. So again, right here in this missing number, you put 45/8. All right. Second one is done the exact same way. We have 6 4/5. Again, I've made lots of videos on these. Take the whole number, 6, times it by the denominator, which is 5 in this case, and then add the numerator. When I do that, I get 30 plus 4, which is 34. So in this case, it'd be 34/5. All right. Last one, basically substitution problem. All right. The first one here, we have 6, and they tell you what J is. J is 4. Okay. J is 4, so we're going to do 6 times 4 minus 3. 6 times 4 is 24, minus 3 is 21. Okay? Pause real quick. I got to take a phone call. Hello? Okay. Yep. No. Oh, yes, I do. Yep. Okay. 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 Okay, I'll double check that. You bet, bye. Okay, next one. B parentheses B plus 5. Okay, B is 3. So remember, this means B times B. So we have 3 times 3 plus 5. 3 times 3 is 9, plus 5 is 14. All right, last one. 8 plus 4. And K is 3.5, so times 3.5. 4 times 3 is 12, plus a half of 4 is 2, so that's 14. So really we have 8 plus 14, which is 22. Those are the answers to 6.2.4.